Hey everyone, welcome back to my channel and another new video. In this video, we're continuing the data structure algorithms bootcamp. And in the previous video, I told you how to work with large strings and mutable strings. We learned about string buffer, how to format your output, so on and so forth. These things are very important when you work with large number of inputs in your QA rounds and various test cases. So we're just going to continue that before we move on to some more advanced structures and do some more finish the trees playlist. But before that, it's important that we now work with large numbers. So if you're given a large number, how can you do that? Let's say it will not fit in the size of int or integer. So yeah, we're going to learn about that. And similarly with decimals as well, let's say something doesn't fit in float or double, then how do you work with that? So Java provides us pretty amazing classes, BigInteger and BigDecimals, which are very, very important when you're working with large number of inputs, be that in your QA rounds or computer programming or whatever. So in this video, we're going to learn about how to work with large integers, large numbers, large decimals, like really big numbers in Java. Let's get started. Okay, so let's first look into how to store large number of integers. Okay, so storing large integers. For that, there's a class in Java called BigInteger class. Okay, you already know about inheritance and subclasses or whatever. We know most classes in Java are the parent class is object class. So here we have the object class. We all know this object class we have done in object-oriented programming. Inside this we have number, java.lang.number in these packages, and inside that we have java.math.BigInteger. Okay, write it down clearly so you can understand. Inside this we have java.math.BigInteger. Okay, if you look at the definition of this class, if you see how it's defined, just control command click whatever. We have done it in the past. If you've been following the playlist, you know what I'm talking about. Just click on it. You will see the internal implementation, command click or control click. So this basically extends number. As you can see, extends the number. So it extends number class and it implements the comparable interface. Okay. Why am I telling you this? Comparable. Because we already covered in the object-oriented programming playlist extends, implements or whatever, right? So when we covered this, we knew that what does it mean by when you say implementing or an interface extending a parent class. We know some properties you inherit, and when you implement, then you there are some abstract functions or methods, then you define their own bodies, so on and so forth. So I'm telling you this because we have already covered number and comparable and all these other things. So you can see what all things these have and what all methods it implements, has its own definitions and all sorts of things. Just in the documentation, like we have seen before, you can find it. Okay, so that's pretty simple. Yeah, that's basically about it. Let's just dive straight into it. Let's use it and see how we can work with large number of numbers, integers or whatever. And let me give you an example of this as well. Let's say we will do a factorial program. So we'll try to calculate a large factorial, which obviously cannot be stored in integer, but it will be able to store in BigInteger. So let's see in practice how to work with large numbers. Okay, one more thing before we get started with the code. What is the range of this? Okay, it's supporting large numbers, but what is the range? So range is pretty simple. Minus 2 raised to the power the integer dot max value till 2 raised to the power integer dot max value. These are both exclusive. You know how ranges can be sometimes inclusive and exclusive? These are exclusive. And also, since it's a class, it will throw null pointer exception. You know, if you try to go outside this range or do any funny things, it's going to do that. So yeah, let's get started with the code. Okay, I have my code here. I'll create a new Java file and I'll call it large numbers. Create. Here we have it, and you can find the link in the description below to all these things. Gonna close this for now, and here we go. So let's say you have int a is equal to 30, int b is equal to, let's say, 67. Then you can create a big integer class. You can say big integer a is equal to, zoom in a little bit so you can see. Here I can say big integer dot value of, now here you can pass a value. So you can say anything like, 33 or whatever. Sounds good? Similarly, I can have big integer of b is equal to value of something. Okay? So you can directly pass some values over here. This is how you did it in primitive types. This is how you can do it in big integer type. Big number you can put over here. 2 raised to power integer dot max is a really big number. Okay? Sounds good? You can also have strings. You can also have, let's say if you have a string, big integer c, you can have a string, something like this. That will also convert it into a big integer type number. Okay? You also have constants as big integers. So the constants you have is big integer dot constant. So 1, for example. There are other constants like 0 also. And there is a 10 also. You can also find it in the documentation. In the previous example, in the previous video I mentioned, for such technicalities and stuff that do not require intuition, we're not studying dynamic programming here. It's just whatever the implementation they have provided us, please make use of the documentation. Here you can find everything about the big integer constructors, all the methods, everything, all the definitions and everything. Okay? Cool? Right. Now let's say we want to do addition of big numbers. How do we do that? So if I have a big integer, sum is equal to, let's say I can say I want to add a and b. So I can say a dot add b. I cannot do a plus b because these are objects. So a dot add b. Okay. If you want to print it, system dot out dot println s. Try to run that. Probably should have imported it. Integer number too large. Oh, it's integer number too large. Okay, no problem. This has to be in the value of integer. That's fine. And big integer I have to import. Import java.math Okay, not the value of when you do strings. If you're working with strings, you have to create a new like this. Hopefully that should be able to, yeah, there you go. So a plus b is giving me the answer. If I just put something smaller, like let's say 5 and 6 should give me 11. Make sense? 11. So this has to be in the range of an integer. You know how if we went about the rate of integer, it was giving an error. But if you have a really large number, you can pass it as a string. So if I have like something like fine, no error, just print C. And this way, so there's two ways. Big integer dot value of, you directly pass the number, or you create a new one. So new big integer dot, so new big integer, this is a constructor you're calling. Okay, constructor that you're calling. Here if I check the constructor, types of constructors should be somewhere here. Constructors, there you go. String value, this is a type of a constructor. You have a decimal string representation and it will convert it into a big integer. You can also have byte value, bit length, certainty, all random stuff. So you can create randomly generated positive big integer. So play around with it. Okay. Print C, run. Looks good. If I create a D, no, not a D, I create an X, and that's another one. S is equal to C plus X, print S. It will give an addition of these two numbers. Sounds good? Very cool. Okay. Okay, don't be confused in the, okay Kunal, why did you not put new over here and why are you putting new over here? See, if we talk about value of, here we go, it is static. I don't have to create a new one. It's just saying big integer dot value of, and you just put a long value over here. It returns a bit integers whose value is equal to the specified long. Okay, no new method has to be, new object has to be created because it's static. You don't know static, we have done static, please watch object-oriented programming playlist. But here, this is a constructor. Similarly, if you talk about value of, if you want to get an int C is equal to, you can put it something like b dot int value. So if you want to convert big integer to int, you can do that also. And this is converting int or long to big integer. Very simple. Okay, but if you're working with really large data, let's say in the form of strings, because this obviously cannot exist in an int format, then you have to create a new constructor and initialize it. Okay, similarly now let's say we can do something like big integer multiply is equal to C dot multiply X, print multiply these two numbers. There you go. So when you're working with large data, please use big integer. Other than that, I can say subtract also. C dot subtract. There you go. Not a problem. Similarly, I can do something like divide. Oh, did not put D over here. 0. If I do X, C, 1. If I reduce it, maybe something like this. Again 0. Yeah, that makes sense. C divided by X. There you go. Looks good. Similar to divide, you also have remainder. You can have remainder. remainder as well. Oh, sorry. X remainder. There you go. If you have the remainder. If you try to do it with primitives, you will get error. Okay. You can compare also a C and X. So you can say if, for example, in primitives, what do? If A is less than B, here what you do is if C dot compare to X is less than 0, we have already covered compare to. Check the object-oriented programming playlist how compare to works internally. So yeah. System.println. Yes. C and X. Yeah. X is smaller than C. That's how you compare. Pretty basic stuff. Right? Okay. You can explore all these things yourself. See, so many things are given. Power, even power, exponent power, this of exponent, and so many things are given. So you can calculate the power, modulo, inverse, shift left, shift right, and or XOR and not. You already know set bit. So many things we have already done in when we were doing maths for the bitwise operators. So many things are here. Hash code and max and toString, 2-byte array, long value, float value, everything is given. Explore a little bit. Okay, by the way, code and everything we can found in the description. Okay, let's say what we do is we create a new file, factorial.java, import BigInteger, class factorial, and static return type will be what? BigInteger, obviously. So we call it fact, it takes an integer number. Not a problem. So my answer is also obviously going to be a type of big integer. Answer is equal to new big integer. Initially, let's say it's equal to 1. Not a problem. And I will return my answer. How do you calculate factorial? How do you calculate factorial of a number? Multiply that number starting from 2. Multiply that number. For int I is equal to 2. I is less than equal to my number and I plus plus. I will just multiply this by my answer. So my answer is going to be equal to answer dot multiply this number I, but I cannot multiply I because it's primitive. In this multiply method inside the argument, it's also type big integer. How do I convert integer to big integer? Value of. That's it. System.out.println factorial.fact for a really big number, let's say this number. That's a big number. Is it gonna work? Is my program okay? So is equal to answer dot multiply integer the value of I. Should be fine. We got the answer, but it's really long. Integer would not have been able to do that. See, still going. So it works, getting the answer at least. So big. Okay, that'll keep on going for a while. Anyway, it's too big. Yeah, here we go. Looks good. program finished executing, but it's a really long number. Try something small. 100. See, it was giving the answer for previous one also, it's just really long. So if you're working with large data, here we go. Big integer. Very cool. Now the next step for you would be just to explore the documentation. Alright, moving on, let's talk about big decimal. So let's say that we talked about big integers. Let's say talk about big numbers that also have decimals in it. If those are not being stored in float or double, how do we solve that? Okay, let me show you something. Hold on. Before we move on to big decimal, let's take a question. Let's say big decimal. Right. Here, let's say I'm taking double. X is equal to 0.03. And I say double. Y is equal to 0.04. Not a problem. And then I say double answer is equal to y minus x. And then I try to print the answer. System.out.println answer. What is the answer going to be? Think about it. 0.04 minus 0.03. 0.01. Okay, let's see actually what the answer is. Static void. (0.01) 0.000002. Is this the exact answer? No. Exact answer has to be 0.01. Why are you giving me in the end 2? Because let me write it down in the notes. Okay, now big decimal. Why? So why are we not getting the exact answer? Because float and double primitive like data types, these are floating point numbers. We have already actually covered it, but this is just a revision. Floating point numbers. So these are stored as, this is a binary representation. As a binary representation of a fraction and a power. Okay, exponent. Okay. And the other ones like integers, they are fixed point numbers. Okay. That is why they give some error. We've covered this in the previous lecture, like how these data types are stored. Check out the data types video. But they give a small error of around 10 raised to power minus 19. That is the problem. But big decimal gives exact answer. Okay, because float and double, these are not the they are not fixed point numbers, they are floating point numbers. This is an important point over here. So they are represented with an exponent like a into 10 raised to power minus something or whatever, if you want to represent something. Okay, and that is why it gives a little bit of an error of around 10 raised to power minus 19. Very minimal, but still you will get error. Big decimal on the other hand does not give an error. It will give you the exact same answer. Okay. So same thing for big decimal. Object, number, java.math, big decimal. Object class, number, big decimal, same as big integer. It also has serializable and compared to the big decimal, comparable to the big decimal object. Now range. What is the range? What is the range of big decimal? So it's pretty big. The range, as the documentation says, if I open the documentation, when in doubt, check documentation. So in the first line itself, it says a big decimal consists of an arbitrary precision integer unscaled value and a 32-bit integer scale. If 0 or positive, so if the number is positive, the scale is the number of digits to the right hand side of the decimal point. Not a problem. Okay, that's the scale. And if negative, the unscaled value of the number is multiplied by 10 to the power of the negation of the scale. So unscaled value into 10 raised to power minus of scale when the answer is negative. Okay, pretty simple. Okay, so it contains what? A random precision integer unscaled value, which is not scaled yet. So it depends on the number of decimal points you have, and a 32-bit integer scale. This thing is pretty simple. So if the number is greater than or equal to 0, if it is greater than equal to 0, in that case the scale is equal to the number of digits on the right of the decimal point. Scale is equal to number of digits right of decimal point. Otherwise, the unscaled value is equal to what? 10 raised to power minus of scale. Okay, sounds good. We all know what the scale is, 32-bit integer, but scale is equal to the number of digits on the right hand side of the decimal point if it is positive. Otherwise, it is 10 raised to power minus of scale, whatever the scale is, the unscaled value. Okay, a little bit complicated, but this is how they have decided it to be. It's not really something like you have to worry about too much, because this is not like a concept, it's just a rule. So just try to understand the rule as it is, why they have made it this way or whatever. You can ask the Java community. So don't think about the intuition on this, it's just a rule. That's a rule, okay, no problem. Very complex rule, I get it. Complex for some reason. No one in interview will ask you this. Okay, now similar example, if I give, if I say instead of this, I say big decimal right? I say capital X is equal to new big decimal 0.03. So same rules, just big decimal has changed now. Y is equal to big decimal 0.04. Big decimal answer is equal to subtract. So subtract was just dot subtract. So I can say y dot subtract x system.out.println answer. Oh, sorry. Can't have two answers. It's giving 0.01 exact. Okay. Sounds good. So if you have something like, if I just hide it for a second, A and B, let's perform some functions on this. Let's put a really complex number like this, something maybe 0.1 something something, big number. This will be again point something something. Make it a little bit more bigger, no problem. Operations. What do? Start with simple addition, subtraction we have done, but I can write it down over here. Addition. B dot add A, that's addition. Subtraction. B dot subtract A. Similarly, you have multiply. Okay, if I run this, see, very simple stuff. So you can try out various others as well. If you just check the documentation, you can see all the methods and all the fields and everything. See, abstract, add, byte value, you have divide also, you have power, anything you can try. POW, you want to try power, no problem. Copy paste, B dot power. Let's say we squared B squared. Very simple stuff. Okay. So pretty cool. Negate returns BigDecimal whose value is minus this and whose scale is of this dot scale. Okay. Can try negate. See what it returns. So it's just giving a negative value. Okay, minus of this. So if you want negatives, there you go. You can see there's no loss in pointers over here. Very cool stuff. It also has constants just like big integer. So you have something like, let's say, BigDecimal con is equal to BigDecimal dot 1, something like that. Okay, sounds good. So now you can just explore, play around with it. But yeah, this was an important topic because you are going to be using these in a large number of inputs, and sometimes they ask that in computer programming and like in interviews as well. So you can use that. And we also showed you how to know how it, like the range and everything, how it's structured, because you've already learned object-oriented programming from me, so you will be able to understand what I meant by implements and stuff. But yeah, you can check out the documentation, see what sort of methods it implements, all sorts of things. So we only looked at some of the nice examples for you to work with, but you can obviously check out the documentation, run every example. You might not need every example, but according to your use case, explore the documentation and stuff like that. If you have any questions, leave those in the comment section below. Please explore the documentation. Make sure you like, share, and subscribe and comment as well. Do subscribe if you haven't already, and like and comment. That's the best way you can support my work, because I'm making these videos for you for free. And you can take a screenshot, share it on socials, join the Learning in Public initiative, use hashtag DSA with Kunal, where you can check out other people who are learning from these boot camps. You can join our Discord server. We make devs, and the code and everything you can find in the description below, and you can run it on your browser itself by clicking run. Same code that I have over here. You can fork it and do all sorts of things. Assignments, lecture notes, everything can be found in the description below, and the pin to it as well. And yeah, appreciate it. Thanks for the support. See you in the next one. Have a great day.